Hello my dear students. Today let us go for one more important concept of electrochemistry, electromotive force, EMF, calculation of EMF and problems on EMF. We have seen several electrodes. In all electrodes we connect two electrodes always. What exactly happens when we connect two electrodes with different potential? And if we complete the circuit? We have that doubt from so many times. Let us have an example of a Daniell cell. So in the Daniell cell we have already seen earlier zinc is an anode and copper is a cathode, and both have some different electrode potential. If they are once connected, the electron starts flowing from zinc electrode to copper electrode. So electron moves from anode to cathode. Remember this point. If electron moves from anode to cathode, current moves in exactly opposite direction. It moves from cathode to anode. It's a point to be remembered. Here the electron moves from zinc electrode to copper electrode. But the question is, why? Why the electron moves? The reason is pretty simple. The reduction potential of zinc is minus 0.76. The reduction potential of copper is plus 0.34. As there is difference in the reduction potential, there occurs potential difference or an EMF will be generated. Whatever the difference in the potential occurred, that brings the electron to move from anode to cathode. So we have seen many a times, we have used the term cell potential. What exactly cell potential is? In a simplest term, cell potential means a potential given by a cell or the voltage given by a cell. But let us go for the definition. Cell potential is the difference between the electrode potential or the reduction potential of cathode to anode. This is important. Cell potential is the difference between electrode potential of cathode to anode. Cathode is first, then comes anode. We should have to subtract from electrode potential of cathode minus electrode potential of anode. So if we doing this, we get electrode potential, the cell potential in terms of voltage. That's what we call it as electromotive force. What exactly that electromotive force or EMF is? EMF is pretty simple. It's a potential. It is a potential, cell potential. When no current is drawn from the cell. It's a cell potential when no current is drawn from the cell. It means no current is utilizing in the cell. Only we are measuring the potential difference. That's what we call it as EMF of the cell. The definition is like this. No current is drawn from the cell. When no current is drawn from the cell potential is itself called as electromotive force. Let us take this thing laterwards. Let us take a cell. For a cell, M1 bar M1 N plus, that means it is acting as anode, and M2 N plus bar M2, it is acting as cathode, because here the oxidation is taking place from a metal to metal ion. Here reduction is taking place from a metal ion to metal. Remember, which one undergoes oxidation? The one which has lower value of SRP. The one which has a lower value of SRP, it undergoes oxidation and acts as anode. The one which has higher value of SRP, it acts as cathode. Because it undergoes reduction. So EMF of the cell, as I have told earlier, cell potential or EMF of a cell is calculated by a simple formula: E right minus E left. E right minus E left, or I have told you in the definition itself, E cathode minus E anode. So cell potential is the potential difference of cathode to anode. E cell does Ca. Remember this shortcut. E cell does Ca means E cell is E cathode minus anode. Cathode minus anode. Remember, for all working cell, they always contain positive E cell value. Cell potential will be positive for all working cell, or the cell which exists, which can produce electricity. It must have to have positive value of cell potential. So that's why there must be cathode minus anode. Let us take this Daniel cell as an example, in which zinc is undergoing oxidation, so that's why it is anode. Copper is undergoing reduction, so that's why it is cathode. So E right minus E left, or E cathode minus E anode. E right minus E left, or E cathode minus E anode. So here cathode is what? Cu2 plus 2Cu. This is a cathode. And anode is what? Zn2 plus. But remember, we should have to take EZn2 plus to Zn. Why we have taken it like this? This is pretty important, where the students usually make mistake. Here we should have to take reduction potential always. EZn2 plus to Zn stands for the potential when zinc 2 plus converting into zinc. In fact, here it is in negative value because zinc is undergoing oxidation. But we should have to take reduction potential always whenever using this formula. E cell is equal to E cathode minus E anode. We must have to take only reduction potential, not oxidation potential. So let us have some problems. Given standard reduction potential values, arrange the metals in the increasing order of their reducing power. That means the increasing order of their strength of reducing agent. Which one that acts as reducing agent? Which has a ability to undergo oxidation easily. The one which undergoes oxidation easily, it acts as good reducing agent. The one which undergoes reduction easily, that acts as good oxidizing agent. Let us look for the values. See, if anything which has more value of reduction potential, means it has strong tendency to undergo reduction. If it want to undergo reduction, then it has to do oxidation. So that's why it acts as a strong oxidizing agent but not reducing agent. Here, reduction potential of Ag plus to Ag is 0.8 plus 0.8. It is highest among the others. So that's why it acts as weakest reducing agent, or the reducing power is minimum. Same way, the reduction potential of potassium is very less. It means it has no tendency to undergo reduction. In other words, potassium has high tendency to undergo oxidation to form K+. So that's why it readily undergoes oxidation by reducing the other species. So that's why it acts as strong reducing agent. This is the weakest reducing agent and this is the strongest reducing agent. So that's how we can arrange them. arrangement of metal in the increasing order of reducing power. First one is silver, highest reduction potential 0.8, then comes chromium minus 0.74, then comes mercury minus 0.92, then comes magnesium minus 0.36, then the one which has lowest value of reduction potential, potassium, among here, so which acts as very strong reducing agent. Let's have the second problem. Calculate the standard EMF of the following. They will give some values of cell potential or the standard reduction potential of some metals, and we should have to calculate the cells formed by them. We should have to assume that these all are working electrode. If they all are working electrode, then reduction potential of cathode must be more and reduction potential of anode must be less. That point we should have to note down. So they've given many values. Let's go for the first problem. Cell formed by copper and zinc. Copper has a reduction potential of 0.34 and zinc has a reduction potential of minus 0.76. Then which one has to undergo oxidation? Zinc has to undergo oxidation because the one with low reduction potential acts as anode, the one with high reduction potential acts as cathode. So here copper is a cathode electrode and zinc electrode is anode. So substitute the reduction potential plus 0.34 minus of minus 0.76. So minus of minus is plus. Its value is 1.1 volt. We have seen earlier cell potential of standard Daniell cell is 1.1 volt. So that's how it is to be calculated. Second question. The cell formed by zinc and magnesium. If it have to be a working cell, the one which undergoes oxidation or the anode should have to have less value of, look at here, should have to have less value of reduction potential. So that's why anode should be magnesium and cathode should be zinc. So the E-naught cell will be equal to E-naught cathode minus E-naught anode. E-naught cathode is what? Zinc minus copper. So minus 0.76 minus of minus 2.36, and the answer will be 1.6. Look at here, it's a working cell because it has positive value of voltage. EMF must be positive. Remember, for all working cell, the cell potential or the EMF of the cell will be positive values. Third question. The cell formed by copper and silver. So copper is also having positive value, silver is also having positive value. Then look for which one is higher. So silver has high reduction potential than copper, so that's why silver undergoes a reduction, that means it acts as cathode, and copper undergoes oxidation, it acts as anode. So that's why E cell will be E cathode minus E anode, that is E silver, E naught of silver and E naught of copper. So silver electrode minus copper electrode, the value comes plus 0.80 minus plus 0.36. It's minus 3.36. Thank you so much. Thanks for watching.